Now I shall make introduction to chapter 3. We shall study a system of linear equations, and we shall learn how to solve them quickly, effectively and efficiently. The chapter starts a little bit slowly with too many details, and I want to make a more concise introduction and show you how we shall work in sections 3.1, 3.2, and 3.3. And then there will be written notes where more details will be given. Now, things are actually very simple. We are solving systems, and you have seen systems before. Let's start with a simple example. Solve this system. 2x minus 3y equals 5. X plus 6y equals 1. A simple system with two unknowns, x and y, and two simultaneous equations. There are two methods to solve such systems: by substitution and by elimination. We shall work with elimination most of the time, but let me remind you how substitution works. Here, because we have two unknowns, I can express one of them in terms of the other and bring it to equation with one unknown. For instance, from the second equation, I can write x equals 1 minus 6y and put this in the first. So the first equation becomes 2 times 1 minus 6y minus 3y equals 5. And here we have just one variable, y, one unknown. We shall solve it for it. Simplifying here, we have 2 minus 12y minus 3y equals 5. Bring this to on the other side. Negative 15y equals 3. So from here, y equals negative 3 over 15 equals negative 1/5. Excellent. And now remember how x was written in terms of y. X is 1 minus 6y. 1 minus, it becomes plus 6/5. So this will be 11/5. This is how we solve the system by substitution. We can choose to solve first for y, then for x. Doesn't matter. Now I want to show you a better solution by elimination. And we shall do elimination, as I said, most of the time. Here I want to rewrite the system and start from the beginning. This was our system. I can eliminate x or I can eliminate y. Let me show you how to eliminate x. The second equation I will multiply by negative 2 because I have plus 2x in the first equation. Here I'm multiplying by negative 2 to make negative 2x. The new equation will be negative 2x minus 12y equals negative 2. And we add the first and the new second. The result will be 0 minus 15y equals 3. And again, y is negative 3 over 15, negative 1/5. Now we can substitute this in one of the equations and find x. But instead, I shall eliminate y and find x by elimination also. Here, back to the system, I shall now independently eliminate y and solve for x. X plus 6y here equals 1. Now I will multiply the first equation by 2. And the coefficient in front of y will become -6. In the second is +6. I'm writing the new first equation for x minus 6y equals 10. Now adding these two, I have 5x plus 0 equals 11. So x will be 11/5. Both of these unknowns were found by elimination. Now, some remarks about geometry. I'm rewriting the system. Look at these equations. These two equations represent two lines in the plane. In the xy plane. This is a two-dimensional space. There are two coordinates. We usually write it this way, r squared, like 2 times the number line. And solving this system, we're actually looking for points which are common for the two lines. So we're looking for a common point. And we found a common point. Common point is our solution. It will be the point with coordinates 11/5 and the -1/5. So the solution to this system is the common point to the two lines. Two lines in the plane can be crossing like these two. So the general configuration is something like this, and here is the common point. They can be parallel, and then the system will have no solution. The two lines also may coincide, and then you'll have many solutions. All the points on this common line, this double line, will be solutions. These details will be discussed in the accompanying notes. Now I want to continue further and look at equations with three variables. Look at this system. X minus y plus 2 times z equals 5. 3x and the second equation does not have y, so I'm leaving space and I'm writing plus z just under the first z, and this equals 3. Instead of writing 0 times y, I prefer to do it this way. It's good to have one column for x, one column for y, one column for z. And the last equation will be -2x plus 2y plus 3z equals 0. Okay. Actually, let's make one correction here. Instead of 3z, just z. See how I'm writing z with this bar in the middle, because I want to distinguish it from 2. Sometimes if you don't write this bar, if you write like this thing, it looks like 22. So it's good to distinguish z carefully. And this is how I shall write it. So we have here three such equations. And we shall discuss later that these equations represent planes in three-dimensional space. Each equation represents a plane. And we are looking for common points. Now we can do elimination and find x, y, and z. For instance, look, if I multiply the first equation by 2, add to the third, x will be eliminated, and only equation y and z will be left. I can multiply the first by negative 3 to the second, the same effect, and such things. We want to develop a unified procedure, and in order to make computations easier, I shall use only the coefficients, because when we are simplifying a system like this, we are working only the coefficients, and x, y, z, they just show you the positions, we're not changing them. So let's make a table using only the coefficients, table of coefficients. Which we call this matrix. And the matrix here for this system will be 1, -1, 2, 5. This represents the first equation, the first line of the matrix. Then we have 3, 0. We don't leave empty space in the matrix. 1 coefficient here, 3. The third line will be -2, 2, 1, 0. Okay, now we put this in brackets. This is a standard way to write matrices. At least in our book they use brackets. And because the third column here, the last column are the numbers on the right side of the system, they have different row. We put here one vertical bar to show that these are the numbers on the right side on the equality. And a matrix like this, with this vertical bar corresponding to such a system, is called augmented matrix. If we have only zeros on the right side, we don't do this. We don't have a column for these zeros. And now here is this table of coefficients, and I shall simplify it. I want to simplify the first column. We simplify column by column. Column by column. Moving left to right. So I am simplifying the first column, then we try to simplify second and third and so forth in general. Here I can multiply the first line by 2. So 2 times the first line. The first line I shall indicate with number 1 in a small circle. So instead small circles like that, I shall indicate the rows, the lines in this matrix. So multiply the first by 2. Add to the third line. You'll make 0 in the down left position. But why stop here? I can at the same time independently eliminate the coefficient 3 in the second line. So I can multiply the first independently by -3 and add to the second row of the matrix. What will be the result? Here the result I'm writing here below. I can indicate the new position with arrow. From first position with second position, not equals, because we are changing actually this table of coefficients. There is no equal sign. The first row we are not changing. It stays the same. But now the second will be changed. Remember, the first we multiply by -3, add to the second. So +3, -3, 0 here. -3 times -1 become +3, adding here +3. -6 and 1 will be -5. And then -15 and +3 will be -12. Now, this is the new second row. Remember, we also simplify the third, multiply the first row by 2, add to the third. So all the numbers in the first row multiply by 2, add to the third row. And here in this position we get 0. -2 and +2 another 0. -2, actually we multiply by 2, not by -2. We multiply by 2. 2 times 2 is 4, plus 1, 5. And then we have 2 times 5, so here 10. And this is the result. You can think that in the first column we have x, in the second y, in the third z, and the numbers on the right side are here behind the bar. So this is again a system, simplified system. The third equation becomes very simple. It will be just 5z equals 10. You can tell immediately that z will be 2. But I'm not solving for z right now. I want to simplify further. The first column is simplified as much as possible. There is just one number on the top left. And we can simplify now the second. But I'm looking here at the structure of this matrix, and I see that if I add the third to the second, it will make a very good 0 in the third place. So let's do this. Second plus third. And the result will be this. Not touching the first. 1, -1, 2, 5. 0, 3, 0 now, and -2. 0, 0, 5, 10. Making more zeros, you simplify the system. And what next? What next? Next, I can reduce the third equation by 5. So let's multiply the third equation by the third line here by 1/5. And in the second, this 3 here can simply make it 1. Multiply the second row by 1/3, or divide by 3, which is the same. And the result. The first one is not changing all this time. Now we have 0, 1, 0, dividing by 3, -2/3. 0, 0, 1, 2. Very, very simple. Now we can tell that z is 2 because the third equation actually says that z equals 2. You can tell that y is -2/3 because second equation is just y equals -2/3. But we can simplify even further. And this is what we can do. I can eliminate these two numbers. Let me surround them like that. If I add the second to the first, it will make 0 in this position. If I multiply by negative to the third and add to the first, I can make 0 also here. And let's do these things. One by one. First, adding second to first. First plus second. If we do many things at the same time, we can just lose track of the numbers. Adding second to first, this will be 1, 0 now. This 2 stays. 5 minus 2/3 will be 13/3. Yeah. Second is not changing. -2/3. And the third is not changing. 0, 0, 1, 2. Okay. Remember what I said about eliminating these two here using the third line. So we multiply the third by -2 and adding to the first. what will be the result? 1, 0, and 0 now, because this will be eliminated. And behind the bar we have 13 thirds minus 4, because we multiply the last row by -2 and add to the first, so this is it. So this will be 13 minus 12 will be 1/3. 1/3 here. And nothing changes with the other rows. And look at this. I simplified my matrix, and this simplifies the system considerably. Now, if you return to the system corresponding to this matrix, remember, first column is for x, second for y, third for z, and the numbers behind the bar are the numbers on the right side of the equality. Back to system will give you this. First equation will be x plus 0y plus 0z equals 1/3. Second equation tells you 0x plus y plus 0z equals -2/3. Third equation, we know that, z equals 2. So the system simplifies to this. You get the solution. You get the solution. And the solution here tells you this. At the beginning, our system consists of 3 equations with 3 unknowns. These are 3 planes in 3D, in 3-dimensional space. And they have a common point. Common point. This is the point 1/3, -2/3, and 2. Common point for the 3 planes. So when you have 3 planes in the 3-dimensional space, there are many possibilities. They can all 3 of them intersect in one point, like here. They can intersect on a line. They may have a common line. This will be infinitely many solutions, and we shall describe them using one parameter. They may be parallel, so there will be no solutions. And all these options will be discussed later. Now, I want to stop here because I believe you already have some idea about the nature of this work. And in order to solve systems, we shall write a table of coefficients, which is the matrix, and we shall simplify the matrix the same way I did it here. So we have to develop this special technique. Simplify the columns of the matrix, one by one, moving left to right. Sometimes we can do additional operations like I did here. Simplify the third column before the second, because it was convenient. It will simplify the matrix considerably. And this is it. So please read carefully the following notes on Moodle and start doing the homework. Goodbye.